Year 11s, we're going to get you prepared for Biology Paper 2 this evening. We're going to be looking at the two required practicals that are part of the Biology Paper 2 units. Those are going to be the field investigations with the quadrats and transects, as well as the reaction time practical as part of homeostasis. There will be some, and then we'll be recapping the menstrual cycle and the blood glucose regulation for foundation tier. If you are writing the higher tier paper, please stick around. We are going to be doing the negative feedback loop as part of the glucose regulation, so looking at the role of glucagon. And then if you are a triple, please stick around right to the end. We're going to be looking at the decay practical. So to start us off, we're going to be looking at the required practical 7, which is reaction time. This is part of the homeostasis unit because it's looking at the reflex arc and the input of the nervous system. For our hypothesis for this required practical, we are looking at if reaction time improves with practice. So as you can see in the image on the right, we're going to have a meter rule. One person is going to be dropping the meter rule and the participant is going to be catching the meter rule as quickly as possible. The equipment that's going to be used here is going to be used to measure reaction time and then also to test the hypothesis. So by doing repeat trials, is it going to improve the person's reaction? For this on an exam question, you would be asked to identify the independent, dependent, and control variables. So reminding you that independent variable is the thing that we are going to change, dependent variable is what we are going to measure, and the control variable is what we're going to keep the same. Have a think now if you can identify what the independent, dependent, and control variables are. Pause the video here to have a think if you need to. Okay, so for our independent variable, it's going to be the number of attempts. You're going to be increasing the number of attempts, which is going to increase the amount of practice that the participant has. And we're obviously going to be measuring then the distance that the ruler travels before being caught. And we're looking to see if that distance decreases over time. The control variables for this is the hand that is being used, whether you're using a dominant or non-dominant. In the GCSE spec, it does request the non-dominant hand to be used. Another control variable is the distance that the ruler is held above the hand. So making sure that that distance is the same every time so that the ruler has the same distance to fall before entering the hand. And you're also going to have the same distance between the finger and the thumb. So how open the hand is important here because the distance that the hand is open will also interfere with how quickly it takes for the hand to close and catch the ruler. The results table for this practical looks like this. You need to make sure that you're dropping a minimum of 10 attempts. We want a bigger number here so that we can see if the reaction time is decreasing with more attempts. You can also see that there are going to be 2 people being tested here. By having 2 people, you're able to rule out any bias or any variance and really be able to look at the patterns. And you'll also notice that the ruler measurements will be taken in centimeters and then converted using an equation into seconds so that you can get an exact measurement of time. In an exam, the equation that would be needed for this would be provided for you, or you would just be given the results table with the reaction times. Okay, the next required practical we're going to look at is the field investigations. So this is your sampling techniques. At the bottom of the screen, you can see a picture of a quadrat frame. This is how a quadrat frame would appear on an exam. Within the quadrat frame, you can see the buttercup plants. Now, some important things to keep in mind when we are doing quadrat sampling is that we only count the plants that fall directly in the quadrat. We don't count any of the plants that are half in, half out. We just pretend that they are not there. So when you're doing the sampling, you're going to randomly place the quadrat. The ways to make sure that this is random is to use a random number generator to get coordinates and then to place the quadrat at that coordinate. By doing this, we're going to increase the validity of the method. We're then going to count and record the number of daisies in the quadrat, and remember the ones that are half in don't count. And then you're going to repeat steps 1 and 2 10 times. On an exam, the reason why we've bolded 10 times is because you have to be very clear that within the method, you're going to repeat it a minimum of 10 times. The more data we collect, the higher the validity of the results. And then finally, once this has been repeated 10 times, you're going to calculate the mean number of daisies per quadrat. To calculate the mean, you're going to add up the result of all 10 attempts and then divide it by 10, and this will give you the mean or the average number of daisies per quadrat. Now there is another form of quadrat sampling, and this is the use of a transect. So a transect would be a measuring tape or a line at which you would drop the quadrat at regular intervals. Now, I've put a comparison chart here so that you can see the difference between the random quadrat sampling and the transect quadrat sampling. We're going to look at what those differences are and where they could best be used. So as we said previously, the random quadrat sampling is where the quadrat is going to be placed at random intervals. Again, using the random number generator is the best way to ensure that it is in fact random. However, on the transect, you're going to place it at regular intervals. So if the field that you are measuring is 100 meters, you may choose to drop the quadrat every 10 meters for 10 times. The random quadrat sampling is a good use to estimate the population of living organisms in an ecosystem, whereas the transect quadrat sampling really shows the pattern of distribution in an ecosystem. If you were to picture dropping a transect line across a beach or across a shore, you may start at one end with rocks and sand, and then as you make your way across the environment, you might be heading into more wet sand and then eventually into the water. And you can imagine the change in distribution of different living organisms across that very varied landscape. The transect quadrat sampling requires the use of a tape measure or a string, and the random quadrat sampling does not. But you will see that in both cases of sampling, you must repeat this a minimum of 10 times. Again, that minimum of 10 times is really, really important if this were to come up on your exam question. Okay, we're going to do a quick little recap of the menstrual cycle. So this is going to be required for everyone, whether you're foundation, higher, or triple. To start off, the first important organ involved in the menstrual cycle is the pituitary gland, and the second is the ovaries. These two organs are going to communicate with each other to make sure the hormones are being sent in the right direction and that the right thing is happening within the ovaries. So the first hormone that comes into play originates in the pituitary gland and is sent down to the ovaries. This is FSH, or follicle stimulating hormone. On an exam, the abbreviation is fine. You don't need to know follicle stimulating hormone. You can just write FSH. However, knowing the name follicle stimulating hormone does help you to figure out what it does. It's going to take a follicle and it's going to mature it into an egg. The next hormone that is released travels from the ovaries up to the pituitary gland. It is estrogen, and its job is to thicken the uterine lining. It's basically going to prime the uterus so that if the egg becomes fertilized, it will be able to house itself in the uterus and develop and grow. Estrogen is also going to inhibit or stop FSH production. And it's also going to trigger the release of our third hormone, which is the luteinizing hormone. Luteinizing hormone travels from the pituitary gland down to the ovaries, and its job is to release the egg. So the egg that was originally matured by FSH is now ready to be released from the ovaries and travel through the fallopian tube. And if the egg becomes fertilized, then we get the release of progesterone. And progesterone's job is to continue thickening the uterine lining, to inhibit FSH and LH production. We don't want FSH and LH to be produced or released from the pituitary gland if pregnancy occurs, because that would then try to release another egg, which we don't need in the pregnancy portion. So on an exam, this is one that always throws kids for a loop. This diagram shows the changes in the uterine lining during the 28 days of menstrual cycle. So have a look at the numbers across the bottom on the x-axis there, where we start at day 0. You can see day 14 in the middle. Day 14 is our ovulation day, and then 28 day on day 28 would be the conclusion of the menstrual cycle. And it would be the start of the period. So a menstrual cycle always starts with the bleeding, which is why you can see the thickness of the uterine lining decreasing in the first instance. So this is where we have menstruation. And then once it hits its kind of lowest point, menstruation has stopped, and now the uterine lining will begin to build back up until ovulation, which happens around day 14. You can see that the uterine lining has thickened up to a point that if fertilization of an egg were to take place, then it would be able to implant and grow and get nutrients from that uterine lining. So in this question, it says, describe how changes in the uterine lining shown in the diagram adapt it for its function if an egg is to be fertilized. So remembering what I said, the uterine lining is going to be providing nutrients and blood flow to the fertilized egg. I'd like you to pause your video here and have a go at that question, and we will look at the mark scheme in a few moments. Okay, let's now have a look at the mark scheme. So I apologize, this was for 3 marks and the mark got cut off there. So the first job is that it's going to increase thickness is going to build up so that a zygote, remember zygote is a scientific word for a fertilized egg. It's going to allow it to implant in the uterus. It's going to provide increased blood vessels to provide nutrients for the zygote. It's going to continue to become thicker, and eventually it's going to turn into the placenta. If you can remember back to year 7 reproduction, the placenta is attached to the developing baby through the umbilical cord, and the placenta is the main source of nutrients for the baby. It's also going to increase the surface area so that there's more space for the zygote to attach. You may remember, if I flip back quickly, oh, it doesn't let me, the uterine lining has gaps in between it, and those gaps are going to create folds, which then are going to increase the surface area. And it also has increased glands for secretion, and we know that those glands are going to be really important in providing hormone so that the baby can develop properly. The next thing we're going to look at is the blood glucose regulation. So for foundations here, you only need to know this half of the circle. You need to know the role of insulin, not the role of glucagon. So if you can see in the middle there, or at the bottom, sorry, we have our homeostasis, which is our normal blood glucose level where our body is the happiest. However, we don't stay in that state very often. After you've eaten a meal, specifically one that's high in carbohydrates, it's going to cause your blood glucose levels to spike. So where it says high BGL, we're talking high blood glucose levels there. So we have our carbohydrate being broken down by amylase, glucose is flooding into our bloodstream, and it's going to trigger our pancreas to be like, whoa, whoa, blood glucose is getting too high. We need to release insulin. So once the blood glucose is high, the pancreas is going to respond by releasing insulin. Now, insulin's job is to bind to the glucose that is in our blood, remove it from our blood, and take it to the body cells to be taken up for respiration. However, if there is too much glucose for the respiration need in our body, then we can store that glucose as glycogen, and that's going to be stored in our muscles and in our liver. So once again, you eat a large carbohydrate meal, that's going to cause your blood glucose to increase. Your pancreas is going to respond by releasing insulin. Insulin will then remove the blood glucose, or the glucose from the blood, to then restore it to a normal glucose level. Feel free to pause here and practice doing this cycle. If you are a foundation tier, you have reached the end of this recap. Good luck on your exam. If you are higher or triple, please stick around. We're going to be looking at, oh, sorry, I didn't realize there was numbers. Oh dear. So the numbers can help you kind of order your marks now that you've got them there. Again, feel free to pause if you want to go over any of that. Okay, we're going to be moving on to higher tier only content. So with the higher tiers, still looking at the blood glucose, we now have to understand this concept of negative feedback. So we just recapped what was happening at the top with the big carbohydrate meal causing the blood glucose to spike, pancreas responding by releasing insulin, and then that glucose being taken up by the cells for respiration or being stored as glycogen. Now, if you are a higher tier student, you also have to have knowledge of the bottom half of this diagram. So what happens when our blood glucose gets too low? And it brings up this concept of negative feedback where, as I said previously, homeostasis in our body, the normal blood glucose level does not stick around for long. Our body is constantly feeding back information about whether it's too high or too low, and making adjustments accordingly. So when we release insulin and we take up that extra glucose from the blood, we're going to continue to do that until something else comes along and shuts off that release of insulin. And the thing that's going to do that is the next hormone that we're going to be talking about. So when insulin is too good at its job and removes a lot of glucose from the blood, we then end up in this state of low blood glucose. And you're seeing that on the right side of the diagram. Now, the pancreas is going to recognize that we now have not enough glucose in our blood, and it's going to respond by releasing a hormone called glucagon. Glucagon is going to let the liver know that there is not enough glucose in the blood. It's going to tell the liver to start breaking down glycogen and then releasing those free glucose molecules back into the blood so that we can raise that blood glucose back up. Okay, we also have glycogen stored in our muscles, and the same thing will happen. Glucagon will let the muscles know that we need glucose molecules for respiration, and it will break glycogen down, and the glucose will then be used in the muscles for respiration. So once again, in that negative feedback loop, when the blood glucose gets too low, the pancreas is going to release glucagon. Glucagon is going to tell the liver to break down glycogen and to release the glucose into the blood. This will then restore the normal blood glucose level until the next meal. Okay, if you are a triple only student, then hopefully you're still hanging around. We are going to look through the last required practical, which is decay. So in the decay practical, we investigate the effective temperature on the rate of decay of fresh milk by measuring the pH change. Now, I'm going to give you the opportunity to pause the video here and read through this method. Make sure you have your head wrapped around what this would look like, and then we're going to interpret the results as per how we would see them in an exam. Okay, so let's look at the results table for this. So you can see that the milk was stored at 5 degrees Celsius, 20 degrees Celsius, and 35 degrees Celsius. After 0 hours, the pH remained the same, but after 24 hours, we start to see a change. The 5 degrees Celsius has dropped, by 0.1. The 20 degrees Celsius has dropped by 0.4, and the 35 degrees Celsius has dropped by 1.4. So we're seeing a much faster decline in pH when we have a higher temperature. We know that this is a result of temperature increasing the rate of reaction and therefore the decay happening at a faster rate. But if we continue to watch what happens to the numbers as we move from 24 hours to 48 hours to 72 hours, we can see that in all cases the pH is decreasing. And if you read through with me the sentences below that, it says the milk is going to decay and that is going to reduce the pH. Therefore, it becomes more acidic. Why is this happening? Well, the bacteria that are present in the milk carry out chemical reactions to provide them with energy. I'm sure we know which one these are, the respiration reactions. And this process is going to convert the sugar, the lactose, within the milk into lactic acid. Now, lactic acid, it's in the name, it is an acid, and therefore it is going to reduce the pH. So while the bacteria are respirating and using up the lactose, they are also going to be producing a byproduct of lactic acid, and that is going to reduce the pH. And we can see that being really evident across all three temperatures, but specifically evident in the 35 degrees Celsius range, where we have the fastest rate of reaction. And we can see that the pH drops within 48 hours from 6.5 to 4.8. Okay, I want you guys to pause here and have a read through that. Make sure that you are comfortable and aware of what's happening during the decay practical. That brings us to the end of this required practical paper 2 recap. Best of luck to everyone on your exam tomorrow.